Hello, I am Juan-Juan, your Six Sigma instructor, and today we will be talking about two simple but useful tools for root cause analysis, the 5Y and his cousin, the three-legged 5Y.
Juan-Juan, before we start, can I ask you a question?
Sí.
Why do we need to talk about these tools?
Oh, Mimi, good question. Because as a Six Sigma specialist, you need to know how to use these tools for root cause analysis.
But why?
Because the root cause of a problem needs to be identified before implementing corrective actions.
But why?
Because without the proper analysis, you could be fixing the symptoms instead of the real root cause.
But why?
Because without the proper Six Sigma training, it is easy to confuse the symptoms with the root cause.
But why?
Because training is important.
But why?
Because without training, you are not real Six Sigma, and your root cause analysis won't be effective, and you won't be identifying the real root cause, and your corrective actions won't be effective, and you will be wasting resources, and you could get fired for doing that, and then Welcome back. The 5Y is a simple but powerful tool. To use it, you need to ask yourself or your team why 5 times with the objective of finding the root cause of your problem. Although in some cases, you may need less than 5 whys, and in other cases, you may need more. The best way to organize your answers is using a diagram.
Juan-Juan, could you show us an example of a 5Y diagram?
Absolutely. In this example, the problem is broken teeth in gears made in the powder metal industry. So, to start our analysis, we need to ask the first why, which is why the teeth are broken. And the answer is because the pieces hit each other on the green state on the conveyor belt. By the way, in the powder metal industry, green state means that they haven't been through the sintering process. Our second why will be why the pieces hit each other on the conveyor belt. And the answer is because they are placed sometimes too close and sometimes too far away from each other on the conveyor. Our third why will be why sometimes the gears are placed too close and why sometimes too far from each other. And the answer is because the operator placed them by hand inconsistently. And here you need to be very careful. At this point, it will be very easy to determine that the gears are placed inconsistently because it's a human error and assume that you can fix it with training. No. As a Six Sigma specialist, always try to remove the possibility of human error and use technology instead. That being said, our fourth why would be why the operator placed the gears inconsistently. And the answer will be because the belt is not pokey yoke or there is no robot in the process. And our 5Y will be why the conveyor is not pokey yoke and why there is no robot in place. And the answer is because neither of these options were considered during the design of the process. So we have found the root cause of the problem, which is a process design issue and not a human error. The corrective action then is going to be either pokey yoke the conveyor belt so the operator places the gears consistently, or we need to use a robot. I can tell you that we ended up placing the robot. One last piece of advice is to verify that your 5Y diagram makes sense. To do that, read it backwards and replace the word why for then or so, like this. Neither a robot nor pokey yoke of the belt were considered during the process design. So, there is nothing in the process to place the gears evenly on the belt. Then, the operator was placing the gears by hand inconsistently, so the pieces were hitting each other on the green state, so we ended up with broken teeth. As you can see, our 5 whys makes sense, so we can consider our root cause analysis correct. After all this, we need a break. If you work in the automotive industry, chances are that instead of using the traditional 5Y, you need to use the three-legged 5Y.
Juan-Juan, what is the difference between a traditional 5Y and a three-legged 5Y?
Oh, great question, Mimi. In a traditional 5Y, we are looking for the root cause of the problem, while in the three-legged 5Y, we will try to determine three root causes as follows. 1. Why the defect or problem was created. 2. Why it was not detected. And 3. What was the systemic failure? In other words, what process or system failed to allow this defect or problem to happen? In the automotive industry, this third leg usually points to the APQP process, the PPAP, and the control plan. I will discuss those tools in a different video.
Juan-Juan, could you show us an example of a three-legged 5Y diagram?
Absolutely. In this example, the problem is an undersized dimension in the slot of a plastic piece, which was creating a tight fit with a metal bracket, and the customer reported assembly problems for that. As you can see, for this example, we're using a vertical diagram, and in the previous example, we used a horizontal or a step-down diagram. You can use whatever diagram you want. All of them are useful. The first leg is related to why the defect was made, and the metal brackets were too tight at the customer's assemblies. Why? Because the slot on the molded part did not allow for a loose or float fit during assembly. Why? Because the slot on the molded part was slightly below the minimum specification. Why? Because the tool, which refers to the plastic injection mold, was built at the minimum size specified on the print. Why? Because the engineering department was not aware that the brackets needed to float, so the design was made for a tight fit. So the root cause is a wrong process design. The second leg corresponds to why the defect was not detected. In this case, the undersized slot dimension was not detected. Why? Because the slots were not verified during production. Why? Dimensional or functional verification is not required. Why? Because the control plan did not call out the verification of the slots. Why? Because the customer print did not designate these dimensions as critical, so the root cause is lack of designation for critical features in the print. And the third leg corresponds to the systemic failure that allowed this problem to happen. In this case, the manufacturing of undersized slot. Why? Because the manufacturing system did not address critical function in this area of the part. Why? Because the APQP process did not capture this area. Why? The part print or blueprint did not define area or slots as critical or requiring monitoring. Why? This was not defined by the customer, so in this case, the root cause points to the APQP process, but also lack of information from the customer. I know. The customer is always right, except when the customer is not. This concludes the review of the three-legged 5Y. Now, let's go to the final thoughts. And these are my final thoughts. The 5Y and the three-legged 5Y are simple tools to determine the root cause of a problem, but be careful. If not used correctly, these tools could lead to bias or incorrect root causes. And remember, human error is never a root cause. You could even end up blaming the employees' moms for their mistakes.
Wow, that is so wrong, Juan-Juan. Before we leave, could you give us an example of an incorrect 5Y that ends up blaming someone's mom?
Absolutely. In this example, the customer received damaged product. Here we go. The problem is that the customer received damaged product.
But why?
Because the product was damaged in transit.
But why was it damaged in transit?
Because the shipping personnel used the wrong box size and packing materials.
But why did they use the wrong packing materials?
Shipping personnel did not follow the proper procedure.
But why did they not follow the procedure?
Well, they didn't have the proper training.
But why? If they didn't have the proper training, why did they pack the product anyway?
Well, their moms never teach them how to ask for help, so they didn't ask the supervisor, so it's not their fault, it's their mom's.
Wait a minute. It is not their mom's fault. If they didn't have the proper training, they should have asked their supervisor for help or for the proper training. This is their responsibility to do their job properly. They cannot continue blaming their moms for everything that goes wrong in their lives. I cannot believe you are saying this. This is bull.
Well, that's it for today. Don't forget to subscribe. See you next time. And until then, take care of yourself and each other.
This is bull.